Good evening and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on arithmetic sequences. So what I'm going to go through here is find the sum of the first 40 terms of the arithmetic progression 3, 5, 7, 9, 11. So first of all, I'm just going to talk a little bit about the language of arithmetic progressions, arithmetic sequences, what it is that makes them arithmetic and the formulae that we use when we're dealing with them. So what is it that makes it an arithmetic sequence? Well, what makes it an arithmetic sequence is that it is increasing, going up by the same number each time, term to term. So, took 3, add 2 to get to 5, add 2 to get to 7, etc, etc. It could also be decreasing by a certain amount, we're subtracting the same number each time, but the key bit that makes it arithmetic is that it's the same number added or subtracted each time. We call it the common difference. And there's a few letters that we need to be familiar with. The first one is that we call the first term of the sequence A. So in this case, A would be 3. We then say that D is the common difference, and that N is the number of terms. So those are the three important numbers that we need to define. We're going to put into formulae. A is the first term, D is the common difference, and N is the number of terms. So, what we're then going to just quickly look at is a couple of formulae, where the first one comes from, and then I'll just tell you the other one. Thinking of this in terms of A and D, if we start with A, we add on one lot of difference to get the next term. So that would be A plus D. So we've added on 2. If we were going to do that again, we'd be adding on another 2, another D. So our third term would be A plus 2D. Our fourth term would be A plus 3D. And what that means is when we got to our nth term, it would be A plus N minus 1D. Because we always have one less difference than the position of the term in the sequence. So the second term we've had 1 difference, third term 2 differences, fourth term 3 differences, and we can either write that as UN, it's A plus N minus 1D. Sometimes we write it as L, where L represents the last term in the sequence. There's some occasions when we have to use that. The other thing that we need to be able to do is to find the sum of a certain number of terms, and there are 2 formulae that we can use to do that. One is n over 2a plus l, where n is the number of terms, a is the first term, and l is the last term. Now, if I replace this l in this formula here with a plus n minus 1d, then what will happen is I'll have 2 a's. So I could write it as sum to n equals n over 2, 2a plus n minus 1d. So a plus a is where the 2 a's come from, and n minus 1d is the rest of it. This one you'll use most often because it doesn't require you to know the value of the last term. People often forget about this one, and if you do know the last term, it's actually a much more useful one. So for the sequence that I've been given here, I need to define the first term, the common difference, and the number of terms. So my first term is 3. My common difference, which is what the sequence goes up in, is 2. And n is 40 because that is the number of terms that I've been asked to find my sum to. I'm then going to use this formula here, sum to n. So sum to 40 terms is going to be 40 over 2 times by 2 lots of a plus n minus 1, which is going to be 39, times by d. So 40 over 2 is 20, 2 times 3 is 6, 39 times 2 is 78. So what I now have is 20 times by 84, which is 1,680. So what I've just worked out there is that the sum of the first 40 numbers in the sequence 3, 5, 7, 9, 11 going up in twos is 1,680. Using this formula here for the sum to n terms of an arithmetic sequence, and having identified the three key things that I need to know for this topic, which is a, the first term, d, the common difference, and n, the number of terms.